Hello, welcome to Biology 101. Today we're going to discuss the Hardy-Weinberg Principle. Most people know the Hardy-Weinberg Principle as p squared plus 2pq plus q squared equals 1, and also the second part of the equation, p plus q equals 1. So what is the Hardy-Weinberg Principle? It deals with knowing and figuring out the frequency of alleles in a population, such as a homozygous dominant, homozygous recessive, or heterozygous in a population. So how did they get this equation? Well, you have your male and you have your female, and say they mate, and they're both heterozygous, big A, little a, and big A, little a, and you would FOIL like in a generic rectangle like in algebra. Big A here, small a, big A, small a, and drop this, drop this, drop this, and this. Alright, so this is the way you can determine the offspring of a population. So this is how they determine the equation here. So you have your P representing the homozygous dominant, and your Q representing your homozygous recessive. And lastly, you have your, we'll put this together as P and Q, representing your heterozygous. Alright, so from this, how did they get the equation? Well, easily. P being homozygous dominant, dominant meaning big A, in this case, big A. And here it is, here's one right here. That's all I see left. So that goes right there. Okay. Homozygous recessive, meaning big A, small a. Big A, or excuse me, this meaning small a, excuse me, I'm so sorry. And that is right here. Going right here. And lastly, heterozygous, meaning big A, small a. Well, here's one right here. But there's also another one right here. These two together create this. That is the reason why there is a 2 there, because there's 2 of them. And that is how they came up with this equation. So, let's use this in a scenario. So, you have sampled a population in which you know that the percent of homozygous recessive genotype is 36%. So, we know that homozygous recessive meaning both small a's, is 36%, or 0.36, by dividing 36% by 100 to get it out of percent form. So we also want to know, well, this is what we want to know. The regular recessive allele, the dominant allele, homozygous dominant, and heterozygous. So we know that homozygous recessive is this right here, our double A, which is also our Q squared. Alright, so how are we going to get from Q squared, say, to Q, which is equal to our regular recessive allele? So how will we get there? By doing some simple math here. We can do so we have Q squared is equal to 0.36. So we would square root both sides to get Q by itself. And this will equal 0.6 or 60%. Alright, so now we know that this is our Q, or our A. Please hold a second. And since we know that Q here, if we look at our equation up here, since we know Q here, we can plug it into this small equation. So if we have P plus Q equals 1, P plus 0.6 from our Q here equals 1, so you subtract 0.6 from both sides to get P by itself. So that leaves you with 0.4 or 40%, and that gives you your dominant allele, or your regular P. So how would you get P squared? Well, you would take your P, since it's equal to 0.4, to get P squared, you would take your 0.4 and you square it. So 0.4 squared is going to give you P squared is equal to 0.16, or 16%. This gives you your homozygous dominant. And so now we know this, we can now go on to finding our 2PQ, or our heterozygous. So we do 2, and we know that P is 0.4. So we're going to put a 0.4 in here. And we know that Q, just regular Q, is 0.6. So we'll also put 0.6 down here. So 2 times 0.4 times 0.6 is going to give us 0.48, or 48%. So there's a way you can check to make sure your P plus Q, so we'll take our 0.4 plus our 0.6, and it should equal 1, and it does, so that works. And take your other one, say 0.36 plus 0.48 plus 0.16 should equal 1, and it does. And that's a way to double check yourself. So all of these are correct. And if you have any questions, feel free to